Alright, I'm back for round 2 here. Round 1, I made this entire video and I didn't put the sound on. So I spoke for 12 minutes to just film myself writing things. Alright, so round 2, here I go. Alright, so the first key thing when we're working on this solving radical equations with fractions unit is we want to establish our restrictions. Alright, so what x values actually work in these situations? So if we assess all three pieces here, with rads, we know we can't have negatives under the rads. So if we have -2, we have to either multiply by 0 to make it 0, or another negative number to make it actually work. So for our first piece, x has to be less than or equal to 0. Now, for our second piece, thinking about, what numbers work here. Well, obviously not something like 20, obviously something like 10, obviously something like 6. So numbers that are going to be less than or equal to 5. X is less than or equal to 5. X minus 4, 5 minus 4 is 1, square root of 1 works. If we have a double negative, 5 minus -4 is 9, that works also. Now with the last piece, we have a similar rad, right? We have the rad 5 minus x. But what's the difference? It's in the denominator. And what does that lead to? X in this situation can't be equal to 5 because we cannot have 5 in our denominator because that gives us 0. So what do we have here? We have x is less than 5 as our overall restriction. So our answer, if it's greater than 5, doesn't work. If our answer is less than 5, it does work. Now, how do we go about solving this problem? In this situation, we want to get everything over a common denominator. Once we've done that, we drop the common denominator. Alright, so if I look here, with my first fraction, rad -2x, I'm multiplying that by 5 minus x over rad 5 minus x, minus rad 5 minus x times rad 5 minus x over rad 5 minus x equals -3 over rad 5 minus x. So everything's been given that common denominator of rad 5 minus x. So I have here rad -10x plus 2x squared over my common denominator minus, well, we all know things like rad 2 times rad 2 is 2. So the same rule applies here. Rad 5 minus x times rad 5 minus x is 5 minus x over our common denominator. And nothing happens with, nothing happens with our right side. So the rule up top, as we just talked about, and applies to what we did, in past units, is once everything has our common denominator, we just drop it. So we have rad -10x plus 2x squared, distribute the negative, -5 plus x equals -3. And now we gotta solve like we learned yesterday. So we want to isolate our rad piece. Rad -10x plus 2x squared equals, in this situation, -x plus 2. Alright, so how do we clear out that rad? Square both sides. Square, square. When we square the left side, we get just what was under the rad. But on our right side, we have to FOIL. -x plus 2 times -x plus 2, which leaves us with x squared minus 4x plus 4. Alright, so we've taken this from this fraction equation to a rad equation to now just a quadratic. Everything to one side, x squared minus 6x minus 4 equals 0. Can we factor this? Nope. There are no two numbers that multiply -4 and add to -6. So since we can't factor it, what do? Quadratic formula. X equals -b plus minus b squared minus 4 times a times c all over 2 times 1. Alright, so we simplify the numbers under the rad. We break things down. In the end, what do we get? x equals 3 plus rad 13, x equals 3 minus rad 13. Are they the correct answers? Well, what do they actually represent? Well, in this situation, if we figure out what 3 plus rad 13 is, it's 6.6-ish. 3 minus rad 13 is about negative 0.6. All right, so if we go back to our key piece here, the restriction, are both these answers actually okay? Absolutely not. Right? 3 plus rad 13 is just too large. X has to be less than 5. So for this problem, our answer is 3 minus rad 13. It's okay that one answer is extraneous. You might have a problem where both answers are extraneous. You might have a problem where both answers work. Whatever happens, happens, and that's okay. All right, next problem. All right, so a little bit different here. We got 3 fractions. Right, so there's more going on with our denominators. So the first initial thought is, all right, give out your common denominator, which 2 plus rad x, 2 minus rad x, 2 plus rad x, 2 minus rad x. This is insane. Right? We don't want to do that. We want to find a way to make this problem better for ourselves. So what I want you to understand is that you can actually do difference of squares for everything. So we're very used to like x squared minus 4, which becomes x plus 2, x minus 2. All right, we're very used to that. But know what? If we have x minus 4, we can still do difference of squares. So what we've always been doing is square root of x squared is x, square root of 4 is 2. Same idea here. The square root of 4 is 2, but the square root of x is just rad x. There's nothing that we can do in that situation. Right? You could do difference of squares with everything. If you had a square minus triangle. Right, this is a little far out there, but yeah, if I did difference of squares here, rad triangle minus rad square minus rad triangle plus, rad square plus rad triangle. This does mathematically make sense. It's crazy, but the idea is that you could do difference of squares with everything. So if we look at this initial problem, I got this x minus 4. Know what? Difference of squares, rad x plus 2, rad x minus 2. Instantly, I see some similarities here that I did not have in the last problem. Oh, the original setup. Right, so for this piece, hey, know what? Flip it around. Right, now I got my common bubble there. Seeing common bubbles is great. You know, a little bit easier every time you find more common bubbles. What do we do with this one? Well, I see a backwardsness. Right, so I have rad x minus 2, 2 minus rad x. Whenever we have that backwardsness, what does that mean? Pull out the negative 1, and now it's rad x minus 2, which is great because now I see a lot more common setups here. Right, what do I do with this negative? Bring it up, and this becomes a subtraction problem. Alright, so I really have 2 over rad x plus 2 minus rad x over rad x minus 2 equals x plus 4 over rad x plus 2 rad x minus 2. Alright, all set now. So, what do we know about x? What can x be? Well, based on all of these right here, x cannot be 4. If we plug in 4, well, not all those, my bad. Let's refresh. Based on this one and this one, x cannot be 4. If we plug in 4, square root of 4 minus 2 gives us 0, not okay. Now what's the other key thing? With every rad, like this one, x has to be greater than or equal to 0. Right, so for our setup here, our answer has to fall somewhere within this setup. It has to be greater than or equal to 0, and it cannot be 4. Alright, time to solve it. Alright, so I give the 2, I rad x minus 2 over my common denominator minus rad x times rad x plus 2 over my common denominator equals x plus 4 over our common denominator. Okay, so distribute 2 rad x minus 4 minus x minus 2 rad x equals x plus 4. Combine like terms. Negative x minus 4 equals x plus 4. All right, solve for x. Negative 8 equals 2x. X equals negative 4. Awesome. We worked it out completely. We got x equals negative 4. We're done. Not so fast. Why? Not so fast. X has to be greater than or equal to 0. So, in this situation, x equals negative 4 is not greater than or equal to 0. This is an extraneous solution. There is no solution to this problem. When all is said and done, the answer we got doesn't mathematically make sense. And again, that's okay. It is what it is, and that's what we end up with. Alright, one more problem to work on here. Okay, so starting this off, what's the first key thing I see? Backwardsness. 1 over 1 minus rad x equals 1. And I see my backwardsness. So I'm going to rewrite this as negative 1 minus rad x, which means I'm bringing that negative up. I'm making this an addition problem. Rad x over 1 minus rad x. All right, so I set this up now. I see my common denominator. It's a little bit easier now in this setup, and I'm good to go. All right, so 1 over the common denominator equals 1 times 1 minus rad x over our common denominator plus rad x over our common denominator. Drop our common denominators. 1 equals 1 minus rad x plus rad x, which leaves me with 1 equals 1. Great. All right, we worked it out completely. We got 1 equals 1. So, based on previous units, our answer is all reals. But what did I not do? I did not think about the restrictions. What do we have to know in the situation about x? Well, if I look right there, based on that, x has to be greater than or equal to 0. All right, if we have a rad, x has to be greater than or equal to 0. It could be 0, but it has to be greater than or equal to 0. If I look down here, what can x be? X cannot be 1. If we have 1 in our denominator, that means that we have 1 minus 1, which gives us 0, which is undefined. All right, so back at this idea, is our answer actually all reals? No, because we have to factor in our restrictions. So if we want to write our answer in an interval notation way, our answer to this problem is that from 0 to 1, including 0, union 1 to infinity. There's our answer. Everything greater than or equal to 0, not including 1. So, we've had three different scenarios here with these problems. The first problem, you got an actual numeric answer. The second problem, you got no solution. And this problem, we got a range of answers that mathematically make sense. All of them acceptable in these different situations. All right, hope this video helps. Hope all is going well for everybody. If you have any questions, feel free to reach out to me, Mr. McGivney, or hit up your teacher. All right, have a good one, everybody.